All right, page 67, question 5. Now, this example is very critical for quantities. All right. Now we've migrated from your typical structures to something that is used for human um, use. All right. So we've got a guardhouse structure. So somebody's going to be in there. Now, this type of structure can very easily become or converted into a house. All right. So the principles that we're going to be going through, or the methodologies we're going to be going through, are basically applicable to all of those kind of structures. All right. But now there are a few things that you may not understand or you may take for granted, which I need to clear up. And this example is one of the best ones I've come up with to give you. It's not too complicated. At the same time, it accommodates almost all of the things that I need you to know. Also, you'll notice as we progress with this example, the numbers start to become skewed in the sense that what you've been accustomed to 1, 2, 3, 4, 5 in terms of uh, site clearance being 1, 2 being earthworks, and excavation 3 being overhaul, and 4 being concrete work, that may overlap now. And the reason for that is I choose to overlap it as much as it may become a little bit confusing because I do it in the process of construction. For instance, we'll put the foundation on. We'll build the brickwork to the foundation or to the soffit. Soffit is from your materials. Soffit is from your materials. The underside of a slab or beam. Right? Then we put the floor slab on. All right. And then because we're pouring the floor slab, we need to put the mesh reinforcement in. So we're going to be jumping to a mesh reinforcement construction. And thereafter, we'll be going back to brickwork. All right. So you're accustomed to all of the things linked to each other being done individually. Now I'm jumping. All right. So the reason I do that is so that you don't forget to do a calculation. I don't care so much about the sequence. 4 can interchange with 5, 6 can interchange with 8, whatever it is. But as long as you do not forget to do the calculation, because ultimately that's where your marks lie. All right. So that's the reason for that. Well, let's get into it. All right. So we're sitting with this kind of structure. All right. So we've got here a foundation. All right. And if you look at the conditions, remove topsoil, apply 80 millimeters blinding, 15 MPa blinding layer, roof structure to be done by a separate roofing contractor. We haven't done steel work yet, so I completely left this out. Floor slab, 150 mil deep. You'll see why it's 150 mil deep with the reference 100 reinforcing mesh. All right. Use 5 liters per square meter for soil poisoning, something new. All right. Use that brick. All right. 230 mil internal walls and half brick on 10. Excavated material to be spoiled, 9.7. We know what to do with that. And allow for these openings for windows. All right, so let's look at the structure. Now, if you were thinking that the site clearance for this is 5 times 11.6, okay, you would be completely wrong. You would be completely wrong. Why? Because this is the brickwork. All right, this is the brickwork. All right, so that's the brickwork. Brickwork sits on the foundation, right? Brickwork sits on the foundation. So where's the foundation? Now, the foundation lies outside of the brickwork, doesn't it? Now, can you see why the dimensions of your site clearance is completely wrong? It's more than what the diagram shows you, which is something you have to realize. All right. This part may be confusing. We'll come to that. All right. So this blue or light blue section is what? Is what? It is, as described in your question here. Foundation strip 200 by 620 MPa. Here's 200. Thickness, and here's 600. All right, 600. All right, so there's 600. Now, here's the problem. How much more is this? Okay, how much more is this? Now, the good thing we know is 600. And the brickwork is specified as what? Can you see 220? So let's do some simple math. 600 millimeters subtract 220 gives me what? Work it out. Gives me 380. So we've got basically this portion here taken up as 220. So how much is this and how much is this? Obviously, that would be, assuming it's built in the center, as it should be, we got 190. 190. So you give me that this is now 190 and this is now 190. And if that's 1160, so from there to there is also 190, and from there to there is also 190. So what's our new dimension for site clearance? First calculation. Notice, you get this wrong. Think about it, you get this wrong. How many line items down the full quantity are now affected? Quite a bit. All right, so we're looking at 190 plus 1160, or 600 plus 190. Right, length times breadth, what we got? 190 plus 5,000 plus 190 breadth. And that is your new site clearance. All right, to accommodate for the space here, or the extra space, all sides of the structure. All right, so get that out of the way. Let's go into the calculation. All right, let's see. All right, so what is site clearance? One, that is page 67. Site clearance. There you go. All right, site clearance. As discussed earlier about a minute ago, 190. That's 1160. That's 190 times 190. And we're getting 11.98 times 5.38. And here we go, 64.45 meters squared as our site clearance. All right. All right. Far cry from 11.6 times 5. That would be wrong. All right. As I've just explained. All right. Let's move on. Site clearance. Now we know from we've got excavation and 2.1. Remove topsoil. Okay. Now, what area are we removing topsoil? Right now, I had a few students complaining that we need to remove topsoil only for this area here, not this area here. Now, the practicality of that is just not on, right? Some students also say, you know what, we need to clear site only over there, and over there. So what if there's a big boulder there, and what if there's a huge tree there? We build around it? Think about the practicality of these questions when you consider them. So we remove topsoil for everything, right? Because we create a space to work in, right? And we're saying 64.45 times 0.15, and you're getting a value of 9.67 meter cube. All right, what's next? 2.2. All right, normal material. And thankfully, there's no rock or clay or sandy soil in the strata as we excavate, thankfully, and we don't have to do extra work in terms of the extra over, because the question doesn't tell us rock is found at 450 millimeters below natural ground level. So we just assume everything is normal, everything is good. Now, what are we finding normal material? All right, let's go back to the structure. Are you going to excavate everything from here to here? What's going to happen there? You're going to have a big hole in the ground. So what we're going to do, we're going to dig trenches. Right? Not like the previous one where we did the underground manhole. Right? There was a hole in the ground and rolled along the sides, insides, and came up. Over here, we're building on the ground, but we need some trenches in the vicinity of the brickwork and the walls specifically. So let's do that. Right, normal material. Now, what did I just say? We're going to put in brickwork on a foundation. All right, so we're going to be putting in brickwork for a foundation. All right, and we know what the foundation dimensions look like. There's the foundation dimensions. So what are we trying to do now? What am I trying to say? I want you to understand what the numbers in the calculation mean, because if you don't understand it, then you're going to get it wrong. Right? So we're going to be digging. Now, we've cleaned this area. We're going to be digging a trench. This is the shape of the trench. We're going to be digging all around here, 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 all around here. This is going to be standing proud because we're putting a floor on top of it. All right. So we're going to be excavating the dimensions of this here only, not this. The reason I'm spending time on this is because I've observed over the past semesters, some students just didn't get it when it came to this kind of structure. Because our introduction or my introductory structures or calculations, we dug a hole and we did quantities, they naturally assume we dig a hole and do quantities. No, as I mentioned, this is of sorts a residential building. Somebody's going to be in there. All right. So let's do this. All right, normal material. I need to find out, all right, what the perimeter is of all the trenches. What is the perimeter of all the trenches? If I know the perimeter and I know the depth and I know the width, then I have a volume, isn't it? Exactly. So the length, what is the length? All right, where did I get 5.38? There we go, 5.38 here. 5,000 plus that, you got 5.38. All right, what's the breadth? 11.98. Right, minus 600 times 2, and I get 21.56 meters. Oh crap. Now what? All right, so I'm saying all of this is 5.38. All right, now the previous ones, remember I said A and A are equal, B and B are equal, because I've chosen to chop it up. All right, and we know this dimension here to be 600, and this pencil dimension here also to be 600. So there we go. We know the complete distance, 11.98. And if you take out 600 and 600, then we have this portion, 600 times 2, and I got that distance. Okay. All right, and I think somewhere here we're missing times 2 sides. All right, times 2 sides. Let's check that so I don't continue. 2 times 2. There we go. All right, perfect. All right, now that's for the outer walls. But as you can see, there's an inner wall here. Now, this is a rough foundation, right? Familiar from your methods days. All right. Now, it goes in 4 meters till there. But for rough foundation, we continue to the other side. Maybe when we come to brickwork, we'll stop there. But because it's a rough foundation, your foundation continues to the end of the wall. Basically, we close it up. Can you see I've closed it up? If I had another wall here, right, if this was a toilet or something, I don't know, that wouldn't be right. If that's a big one, all right, if there was a toilet here, right, and here's your doorway, I would do the same thing. My foundation would go all the way there to complete a rough foundation, right? So that's why I'm extending all the way to the end. But when we come to brickwork, it stops there. Just brickwork. Foundation all the way to the other end. You basically close the square or the rectangle. There's no cavity here that allows, if there's movement, for this to break away. All right? That's basically one of the reasons for closing it up. All right, let's go. All right, so your inner foundation, let's call it inner foundation. And we're saying, what's it, 5.38 minus 0.6 times 2, and I'm getting 4.18 meters. If I tell you all that up, I'm getting 36.5 meters as my perimeter. Okay. Perimeter. You figure that out. All right. So we're dealing with 36.5 meters of perimeter or for the entire foundation. All right, so let's see. All right, so basically, what does this number represent? It represents all the trenches that we have to basically dig for the structure. All right, so as I mentioned earlier, if we know the length, all right, and let's now find effective depth. Let's say effective depth. All right, what's our effective depth? There we go. All right, there's it. 500 plus 200 plus 800. Sorry, plus 80. Remember the blinding. Don't forget the blinding. All right, but we already removed topsoil. So effective depth is 500 plus 200 plus 80 minus 150, and we're getting a value of 630 millimeters as our effective depth. And now volume. What's our volume? We found 36.5 times 0.63, I got it from there, times 0.6 as what? Width of the trench. And we get a volume of 13.8 meter cube. So we have volume. Now we can move on and we say 3, overhaul. And we're saying 13.8 plus, what was our top side? 9.67, giving a value of whatever, right? That times 9.7 kilometers minus 0.5 is free haul, and we get a value of 215.92 meter cube per kilometer. All right. All right, let's go number 4, concrete. All right, why am I going to concrete? So we've done site clearance, we excavated, removed topsoil, we've dug out trenches, all right? We've got material to move. Now we're going to pour the foundation, right? This part here. Now we're going to pour the foundation, the foundation along with our blinding. So under concrete, what's the first one? Blinding. Let's go with 4.1, 15 MPa blinding. Right. Notice the perimeter that we found. Right. Use once again. Mess this number up. See how far it extends to. Impacts on your marks. Quite critically. All right. Let's see. 4.2 is saying 20 MPa foundation, because after the blinding we put the foundation. Right. And we once again 36.5 times 0.6 times 0.2, right? 0.2 being the depth of the concrete, and we're getting a value of 4.38 meter cubed. Right? All right, what's after that in terms of the structure? So the blinding, I pour the concrete. Right? Now we do the brickwork. Brickwork two-way. Brickwork with two-way. We put in, if this is the floor slab, let's use another color. If this is the floor slab, notice the floor slab sits partially inside, right? This sketch, you should be familiar with already because it's in your notes, right? Where I went into brick sizes and the mesh and the DPC. Look for that sketch, can't miss it, all right? So we are basically doing the brickwork. We're doing the brickwork from here to here, soffit of slab. That's what the brickwork is. We know the height, all right? After the brickwork, from floor to soffit, I'm going to be doing the brickwork from here to here, all right? 150 thick floor, 150, all right? And then once we finished with this brickwork, pour our floor, put in our soil poisoning, put in our reinforcement, and pour our floor, then I'm going to do the brickwork all the way to the roof. Because that's how, or that is the sequence of construction. That's why, remember when I opened up this question, I said, it's going to get confusing because I'm going to be jumping from this part of the structure to another. I'm not really jumping. The calculation may seem like I'm jumping. I'm doing brickwork, then I'm putting concrete, and then brickwork again, as if, you know, I forgot about it. I didn't forget about it. The procedure to build is in that sequence. All right, so let's do that. All right, we did the floor. Let's look at 5. brickwork. And let's call this single. Why single? Because look at the sketch. Look at the sketch. This is single brick. This is a half brick wall. So I'm doing it in the sequence of the wall thickness. All right. So we don't forget mistakenly and leave things out. Right. now these dimensions start to be used literally. All right. So let's look at the width. 5.0 times 2 sides plus 11.6 minus 0.22 times 2 multiplied by 2. All right, let's make head or tail of that calculation or that line. All right, 5, 2 sides, 5 times 2. Now 11.6 is across here. All right, but we're saying 5, so in terms of 11.6, we cut it there. So 11.6 is going to be short what? 220 here and 220 there. Here's 11.6, subtract 2 times 220. And the second one is 2 sides. All right. So 10 plus 22.2, and we're getting a value of 32.32 meters. New perimeter to deal with. This time is for brickwork. Okay, let's check something out. Notice the perimeter for side clearance is actually 36, or perimeter for our foundation is 36, much more than the perimeter for the brickwork. And it's obvious why. All right, as a simple check when you're doing your assessment or when you're writing your exam, if there's a distance here, if it's the other way around, something's wrong. Just don't progress. Stop right there, and check your answers. Because as you've seen from here, how one number is used consecutively. All right, so there's that. All right, we know the meterage, and we're saying now, therefore, how many bricks do we need? 32.32 times 0.5, because that's how high the wall is, times 108, because it's a single brick wall, and we're getting 1745.28 bricks. All right, now moving on. There's my speech. All right, we put that part on. Now let's put this part on. What happened here though? It's not a single brick wall, it's a half brick wall. Can you see? The slab sits within that, basically resting on it. So let's do this one. Let's say brickwork half. Right. Now, where did I get this number here from? 5.56. All right, so let's look at, so that's 4. Where did I get that number from? All right, so we know from here to here it's 5, all right? And we know this is 220 and 220. All right, so how much is it from here all the way to there, to the end? All right, so it'll be 5 minus 2 times 2, 0.22, and you're getting 4.56. All right, so that's where I got 4.56. I'm looking at the inner wall, right? We haven't come up yet. We haven't come up yet because in terms of the sketch, we are still here, down here, right? So I'm trying to find all the bricks from there to there half brick times 0.5 is the height times, now it's half brick, so it's 54. And times 0.5 times 54, right? And you get a 1 in 23.12. Right, so that's the brickwork for all that particular part of the structure. Now let's look at brickwork around it, around the slab. Right, now you're going to ask yourself why we do this, because we're basically using brickwork around the slab as some sort of formwork, because when we pour the concrete, it doesn't spill over. All right, as opposed to putting formwork there to hold it up and all of that. So we actually, building process, we actually cheat, right? But it's accepted building process. All right, so let's work out the brickwork around the slab. The slab is 150 thick given in the question. All right, so let's call this brickwork to perimeter of floor slab. Why are we saying that? It's the perimeter, brickwork all around, and the floor slab is sitting inside there. So we call that brickwork to perimeter of floor slab. All right, so perimeter is what? You figure that out. All right, 105, one brick. One point 0.15 is the thickness, or the height, if you will, times 54 bricks for half brick, and you get a value of 265.52. All right, so we've done the brickwork. From there to there, all around there. All right, what's next? Let's put the floor. All right, we know the floor slab is 20 MPa. All right, so what's the dimensions of the floor slab? All right, the floor slab is now sitting inside this area here. Right, remember we just calculated the number of bricks for this section here, the formwork, if you want to call it that, and that's the dimension we're looking at. All right, so let's complete it all the way, basically all the blue lines, where everything within the blue line is now the area of our floor slab, and subsequently also the area of our mesh reinforcement and our soil poisoning. All right, so if we find the area of the floor slab, we actually find two other things, two more things. Easy marks there. All right, and let's put the floor slab on. So we're saying 20 MPa, and we're getting a value of what? Now let's move on to another page. All right. And it's 150 millimeters thick, area times that, and we're getting a value of 8.18 meter cube for our floor slab. All right, why are we there still with the floor slab? Let's put in the soil poisoning and let's do the calculation for the reinforcement, because we're familiar with the values now. So soil poisoning. 5 liters per meter squared, and we're getting a value of 272.8 liters of soil poison. And let's look at reinforcement. Now what do we get? Mesh. Slow down. Mesh equal to 54.56 meters squared. So within that floor slab calculation, it assisted us to find two things. And we're looking at a potential 2 marks there and another 3 marks there. All right, 5 marks for something you already found. I just want to see your understanding. All right, now where are we in the structure? So we've done quite a bit. That, and everything inside. Now let's complete this. We just need to go up. So what's remaining of the structure? Brickwork to the roof height and mortar for that brickwork. So let's continue. Brickwork to roof height, let's call this. To roof height. And our height is equal to 1000 plus 900 plus 1105. We get a value of 3.005 meters. Right. We know the perimeter is equal to what? We found this already. 32.32. Therefore, 32.32 times 3.005 times 108 gives us 10,489.3 bricks. But remember, there's cavities or holes in the structure. What are they? What are they? The windows and the door. So we've got one window, one door. Now those don't take up bricks. You need to remove them. Right? Let's take that. Right, and let's put in here minus door plus window, so we don't forget what we're doing in our calculation. All right. All right, let's move to another page. And here, let's say door. Our door is now 2.005 times 0.905 times 108 because it's a single brick wall, and we're looking at 195.97. And our window, we know the dimensions because that's given to us, is equal to 0.9 times 1.735 times 108, and we get 168.64. All right, so we take 10, 489.3, and we subtract this 195.97 plus 168.64, and we get a value of 10,124.969 bricks. Right? That's for the outside walls. Now let's look at the inside, a half brick dividing wall, half brick inside wall, and we're saying it's 4 meters given. It goes up 3.005, and we're using 54 bricks per meter. All right? But then you may think that this is the easy way out. Remember if you look at your house, or when you're standing in your room and you look at the entrance door, right? Here's your wall, right? And your door is maybe seated there. Here's the door frame. Is the door handle, isn't it? All right, and we're saying that from here to here is 4 meters. but there's a door inside. All right. What about this section here? All right. So let's do a calculation that includes this one. Therefore, this will not be applicable. All right. Let's say now we know length of that structure is 5 meters. Subtract 0.22 times 2 times the height of 3.05 minus the area of the door, which is 2.005 times 0.905, and we get 13.70 minus 1.81, and we're getting 11.89 times 54, because it's a half brick wall inside, 641.97 bricks for that inner wall. All right, now we're doing walls. Let's look at the mortar. All right, now you could, because you know later on that here you could have done mortar calculation. You could have already done a mortar calculation. I can't stop you, right? You're free to do that. Or you can do it like how I would like to do it. All the mortar in one section. It's basically going back to your previous calculations and extracting some of the numbers. All right, so let's look at, let's get say mortar. Notice I didn't put a number there. I'm lost now, okay? Single brick. So don't be intimidated, don't be fearful that I didn't put a number there. All right. When we quantify or when we start to log or basically fill in our bill of quantities, all right, I don't want you leaving out items. Okay. So I'm not so much more worried about the sequence. Oh, this should be here, this should be there, I'm going to take out marks. No, this is about quantities. As long as all of them are there, I'm giving you something. All right. 2 times 0.5, and we're looking at right at the bottom, we're starting 16.16 times 0.05, right, per meter cube. Remember this value from the table in estimation. That's where I got it from. And we get a volume of 0.808 meter cube, right? 0.5, which section is this? The section here, from there to there, right? Mortar for that section. All right, let's look at the next one. 32.32 times 3.005. I'm going above the floor now. And we said minus door plus window. And we're saying 97.12 minus 1.81 plus 1.56. And I got an area of 90. Remember, I did area of brickwork here to find mortar. So that's what I'm finding. 93.75 meters squared. And this is single brick right there, and 0.05. And we get a value of 4.69 meter cube. And our total for this is now 5.49 meter cube. All right, so mortar still. Now we're doing the half brick. All right, 4.56. Remember from there to there, 4.56 times 0.5 high. We're getting 2.28. 32.78 times 0.15. And what's this? Right, this is around floor slab. And we're getting area there of 4.917 meters squared. Right. All right. What else is half brick? Half brick is the inside wall. Here's there. That's the area. All right. 11.89 meters squared there. So what is the total area of our half brick? Half brick being that one and that one and all around there. Notice we've got 3 of them. Right, getting a total there of 16.807 meters squared. Now, half brick is a different volume per meter squared, and that's 0.02. Check that table out to confirm, and we're getting a value of 3.4 meter cube of mortar. All right, so we've quantified basically almost everything that's required for this structure. Not the roof, that's been done by somebody else. Now let's complete this by bill of quantities, or basically go into a bill of quantities. All right. Now you can page through and get through all of these things on your own. I tend to break things down so that when I start quantifying my bills, I don't have to go running looking for them and missing out things. Right. So what I'm going to do here now is let's go at total brickwork. Total brickwork. And I just want to get a feel for all the numbers. I'm getting single, and I say what we said, 2 floor, soffit. We got 1745.28. All right, and then 2 roof. We got a value of 10,124.69. And then let's look at half brick. We got 2 floor soffit here. Soffit. We got, what is the 2 floor soffit? It was 123. To first off, I think we got here 123.12, and then around floor slab we got 265.52, and the inner wall we got 641.97. All right, and if we tally all that, I'm getting a value of 12,927.28 bricks, which we will go for the next 100. Our mortar, simple one, single, we came up with 5.49, and with our half, we found it is now 0.34, and our total mortar is 5.83. Now, if you look at my breakdown, all right, if I have assigned 10 marks for that, now if you break it down for me like this, I know where you went wrong. So I can just take off 2 from you. So you're getting 8 out of 10. You are giving me an opportunity to give you marks, as opposed to just give me one value and boom, I'm supposed to figure out something. All right, so bulk quantities, I'm going to leave that for you to do. All right. And understandably, because multiple things are spread out here, I want you to do the bulk quantities in an order where I can see line items, I can see a total value. Even if you want to say brickwork and put in each one of these line items and put a number there that shows me the tally, it gives me a better understanding of where you may have went wrong and more opportunity to give you more marks, as opposed to just putting a line item, brickwork, boom, 12,000 and 970. Then I gotta go looking now, because if it doesn't match up with mine, where did he go wrong? All right, so let's leave that bulk quantities.